Okay, so we're going to cover section 3B. But before we do that, look, I skipped chapter 2 for this class. And one of the main concepts in chapter 2 is unit conversion. So I'm going to talk just a minute about unit conversion, and then I'm going to go over this section. And it's one of those where I had to decide what to cut from the class, chapter wise. And chapter 2 was something that we decided upon. I say we kind of decided that as a math faculty. Okay. So let's look now at really unit conversion and how to convert from one unit to another. And I'm going to use their examples in this section. I think I did a good one. Yeah, let's just do time first. Okay, let's say I wanted to go. I slept one night for, let's say 8 hours. And I want to convert that to, let's say, minutes first. So convert to minutes. We'll do B and C here in a second. We're going to convert hours to minutes. So if we're going to do this now, I'm going to work this the way your book does it. There's a lot of different ways to convert units. So this is just a review on converting units, okay? There's a lot of different ways to convert units. I'm going to do this really fractional way that I honestly think it's the best way to do it. And your book does it as well. So that works out quite well. So converting units, I want to convert 8 hours to minutes. Well, we have to know how many minutes are an hour. Well, we know that there's 60 minutes in 1 hour, right? So let's start with the hours that we slept. So 8 hours we slept. Now we're going to multiply this by 1, really, but it's a ratio, and that ratio will give us 1. We know there's 60 minutes in 1 hour. Now our goal here is to get rid of hours. So whatever unit we're starting with that we want to get rid of, that unit needs to be on the bottom, okay? Hours. Now we're going from hours to minutes, so we're going to put the minutes on top. And look, we're going to write the equivalent ratio here. So there's 60 minutes in 1 hour, right? This is just 1. 60 minutes divided by 1 hour is just 1. So you're going to have what you start with. For us, it was 8 hours. And if we want to convert this, we would actually just put the unit we want to get rid of, hours, on bottom. So when you multiply this through, what happens is the hours cancel, and you do 8 times 60 divided by 1. Well, divided by 1 is not, you don't have to worry about it. So 8 times 60, which is 480 minutes. Okay, so we slept for if we slept for 8 hours one night, we actually slept for 480 minutes. Okay? Questions? I'm going to do a few more examples of these, so hopefully they get a little easier. And it's not that there's going to be one in the homework that asks you just to convert units, but you're going to use unit conversion in the homework. So let's do part B. I'm going to do a different example. Let's say we slept for 6 hours, and I want to convert that to seconds. Now I'm going to have to do 2 conversions for me because I don't know how many seconds are in an hour, but I can convert down to it. I know that 60 minutes is equal to 1 hour, right? And I know 60 seconds is equal to 1 minute, right? So these 2 conversions will get me down into seconds. So to go from hour to seconds, I can go from hour to minute and then minute to second. Okay, so it's going to take us 2 fractions to get us to this, to down, for me anyway, it's going to take 2 conversions to get us from hours to seconds. And I want to show you how to do that. So we do 6 hours. Now the first fraction, I'm going to get rid of the unit we start with. So I'm going to call that HR for hours because I ran out of space. And just like before, we know there's 1 hour for 60 minutes, right? That's going to get rid of the hour. Now that'll leave us with minutes, but remember we want to get down to seconds. So I'm going to make another fraction to get rid of the minutes. Okay, now we know there's 1 minute and 60 seconds. 1 minute. Again, I'm going to put the minute down here because it's going to cancel the minute up here, and it's going to leave me with the second unit. So now check this out. Just looking at the units, the hours are going to cancel with that hours. The minutes are going to cancel with this minutes, and it's going to leave me with the seconds. So we wind up, now we have to multiply across 6 times 60 times 60. So I'm going to do this. Calculate 6 times 60 times 60. We end up with 2,000 or 21,600 seconds. 21,600 seconds. So to convert 6 hours to seconds, I would have to first go to minutes and then go to seconds. So I need to make two different parentheses, or two different, ratio statements. Equivalent ratios, I should say. Okay, let's think of another one. Maybe that is a little different. Okay, yeah, let's say we are running long distance and we run 5 miles. Actually, let's run 6 miles. I'm thinking, well, how many kilometers would that be, right? And I know you can go to your phone, but trust me, there's going to be some unit conversions that you might not be able to go to your phone with. So that's why we need to go over this this kind of notation and this operation. So let's say we ran 6 miles, and we want to convert that to kilometers because now we're in Canada. And I want to brag about it on my social media. Well, the Canadians don't know what miles are. So I'm going to look up how many kilometers are in a mile. Except actually, I know this. I know that a 5K, so 5 kilometers, is equal to 3.1 miles. My kid runs cross country, and I just know that. Okay, so I know 5 kilometers equals 3.1 miles. So I'm going to use that to go from miles to kilometers. So I'm going to say, I'm going to start with 6 miles. I'm going to use MI for miles. Times, now I've got to have the miles on bottom, right? So the 3.1 is going to be on bottom, and my kilometers is going to be on top. So 5 kilometers, km, okay? So this would be my, this is really just 1. 5 kilometers divided by 3.1 miles, that's just 1, right? So I've got to multiply that by 6. So now when I do this, I'm going to say 6 times 5 divided by 3.1. And the miles will cancel, and it's going to leave me with kilometers. So we wind up with 9.6, let's round to the hundreds place, 9.6 8 kilometers. So if I run 6 miles, that's the same as running 9.68 kilometers because we had to change the unit, right? We had to change the unit, kind of neat. Okay, now if you need help with that, you can go back to chapter 2A or section 2A. 2A talks about unit conversion, and really 2A and 2B. So if you need help with that, you might want to go back and look just to get if you need a more deeper review. If not, that's fine. But we're going to start now with the section 3A part. And the first thing in section 3A is a scientific notation. So writing, large and small numbers. So we're going to talk about scientific notation. Scientific notation was developed to write really, really, really big numbers and really, really small numbers easier. Okay, it's really just a way to move the decimal place and make a really, really big number, a really small number easier to read on paper. And the way we do this is by really kind of manipulating the fact that all of our numbers are written in base 10. So let's look. I'm going to do this with examples. Okay. So let's say, let's look at the debt, total debt, or the debt calculator. I think there's a debt calculator that's always rolling. National debt clock. That's what I was looking at. Okay. Right now it's always moving, but the national debt clock has the U.S. debt at 27. I don't know what number that is yet. Let me write all these numbers down. 860 for, I think that's a trillion. 048, and then I'm gonna say 80000. It's already lapped since we've sitting here. It's at 49 there. So let's just pause it right here. Let's say the debt calculator is at, now this is what, hundreds, thousands, millions, billions, trillions. The debt calculator is at 27 trillion, 860 billion, yada, 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 yada. But this is hard to write, right? That's a lot of stuff going on. So what scientific notation does is it actually puts this big number into base 10. And to do that, you multiply by 10 raised to some number. And for this one, you need to think of this. Let's use another color here. Let's use, what other colors I have going on? Use green. Perfect. Really should be red, but let's look at green. So I'm going to take this decimal, and I need to move it always in front of the last number. So there's got to be a number here, a single number from 1 to 9. Okay, there's always got to be a number here, and we're going to move it. So here's the decimal. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We've got to move this decimal place 13 places, okay? And the way we would write this is 2.7860488. We don't have to worry about all the zeros after that. Times 10. That's always times 10. Now, if we need this number to be bigger, look, 2.78, it's got to turn into 27 trillion, right? We need this number to be bigger. We're going to use a positive exponent here, so it's positive 13. So these are the same two numbers. Now, if you wanted to round it, you can say 2.79 times 10 to the 13th power. But this is scientific notation, okay? This is scientific notation. You always have one number to the left of the decimal, and you're always multiplying by a 10 raised to a power. Now, if you need this number to be bigger, it's going to be a positive 13. If it's smaller, it's negative. We'll do one of those here in a minute. Okay. Okay, so let's look at something really small. Hold on, let's see. Let's see something that'll give us like a size of something really small. I'll steal the one in the book. It says the diameter of a hydrogen nucleus is oh man, that's a lot of zeros. Hold on here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Holy cow. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 1. Okay. And is that meters? So this is the size of a hydrogen nucleus. Bunch of zeros, 1 meters. Now, for this one, if we want to get this into scientific notation, we have to move the decimal to the right. So we've got to move the decimal to the right on this example. So let's do that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It's got to go to the place where there's one number to the left. Okay. So this would be 1 point. Now you can write 0.0 if you want, you don't have to. 1.0 times 10. Now, because we need this number to be a lot smaller, right? It's 1.0. Look, this is a lot smaller than 1. So we're going to use negative, and we move the decimal 15 times. So 1.0 times 10 to the negative power, okay? Times 10 to the negative. Okay, so let's do an example that's in the book now. This is example 2 on page 137. It says using or checking answers with approximation. It says you and your friend are doing a rough calculation of how much garbage new city residents produce every day. You estimate that on average, each of the 8.3 million people, residents, produce 1.8 pounds or 0.0009 tons of garbage a day. I'm just writing down the important stuff. So we've got 8.3 million residents, and you think they produce 1.8 pounds, or we're going to use tons here, 0.009 tons of garbage a day. And you want to know, well, how much is produced total in a single day? Well, so we could say 8,300,000 times, now this is the unit conversion, so that's the number of people, right? Times 0.0009 tons per person, right? So your friend quickly presses calculator buttons and tells you the answer is 225. So look, but notice the people cancels, right? If you've got 8.3 million people times, you think each person produces 0.009 tons of trash a day, right? So that's tons per person a day. That'll leave you with tons. So yeah, if you calculate that, I assume the book says it's 225 tons a day. Okay. So now the goal of this question, though, is actually to see if you can check it using scientific notation. And it says, now the solution, you can write 8.3 million as 8.3 times, now let's write this as in scientific notation. 8.3, so I'm going to move it to 1, 2, 3, 4, 5, 6. I need to be a positive 6 because it's bigger than 8.3, right? 8.3 times 10 to the 6 becomes our 8.3 million. Excuse me. And then 0.009, that would be 9 times 10 to the, now we're going to have a smaller number, right? 1, 2, 3, 4. So negative 4. And what's kind of neat is you can multiply the 8 and the 8.3 times 9 and the 10 to the 6 times 10 to the negative 4. Well, 8.3 times 9, which I still need a calculator for. Oh, I got 74.7 times. Now 10 to the 6 times 10 to the negative 4. You know, with exponents, you add the exponents together. So you get 10 to the second power. So it actually gives you 7,470 tons. So he was wrong, right? It's not 225 tons. It's closer to 7,470 tons, right? This answer of 225 is off. So he must have punched it in his calculator wrong. So it's just a way to check your answer. Okay, I'm running out of time here. So what I want you to do is actually read the rest of this section, and then we're going to go over it in the next lecture. So I hate to say, oh, it's not hard. I don't mean it that it's hard or not hard, but I want you to read through it and then start working on the homework, because what you'll see is you might understand a lot more of this than you realize, because this is a lot of real world mathematics. This is the stuff that you can kind of visualize a lot of times. Okay. So I want you to read the rest of this chapter and then work on that homework, which again, I'll write down for you. So this is 3A homework. 3B. Homework's going to be 1 through 75 odd. And again, on this one, just like the last one, you could probably do every other odd and you would hit all of the homework. It starts on page 147, guys. So I want you to work on that. The next lecture, I'll answer any questions at the beginning of the next lecture if you have questions from this section. Okay, if something just doesn't make sense. So